Good morning. Good, people are still here. Thank you very much. So you probably expected a lecture on, let's say, Go, or an extension of that one. No? Yesterday, Marish talked about Go. Good. Did he mention that he's not here today? Good. So I mentioned it to you. So he's not here today. But it's a good opportunity for me to fill up some gaps. Sorry for the excitement, I didn't pre-warn you. About regarding Linux, because there are a few more things that we want to talk about to make you confident Linux users, I guess. Quite important that we cover a few more things that have been kind of fallen, I haven't been able to cover because last Wednesday the lecture was a bit short. So, but it's also important later on for you when you run on servers, on cloud servers, cloud applications in Golang, that you need to consider certain things that are important. And again, the ops people may know all that stuff, but I think the programmers haven't seen it as of yet. And the things we want to cover in Linux, which are a bit more tricky, are permissions. Actually, I should say POSIX, that is pretty much in all Linux systems. I'll come to that in a second again. But the principles are quite interesting of how the permission system is created there, unlike in Windows, as you may know. That's one of the aspects. The other aspect I want to touch upon is software management in Windows. Sorry, not Windows, Linux, which is also kind of, there's multiple pathways to do the same thing, but it's probably good to understand them. And I wanted to briefly show you a tool called VI or Vim. Who has come across this tool? Good. 1, 2, yes. Cool. Do you sense excitement when you talk about this tool? Or frustration? Frustration, good. Excitement? 50-50, you guys don't want to touch it, never see it again, right? Good. Okay, that's about right. But there's a reason why we talk about this tool, and we got to that when we get to that. So if you have enough questions to drag out the discussion before that, we'll not touch off the VI, so you're lucky. So if you want to get out of this, keep me busy. But no, we don't want to make it hard, but the idea is still, we want to expose you to that tool so you know what it is. And most important, you know how to get out of it in worst case, because that's not primitive. And so much about VI. All right, cool, permissions in Linux. So in the last session, that was last Thursday, 1 week ago, we talked about the idea that you need to navigate the file system. We talked about that different users have different home directories, for example. We talked about the directory structure, if you recall. Right, that was fairly uniform. This thing, right? So kind of the boring standard structure that you know. But one of the things that we also need to talk about, we talked a bit about how to create files, how to use files. There's a lot of stuff that I didn't talk about. But one of the aspects we didn't really cover was permissions. And that is for a reason, because it's a non-primitive task. But it's important to, I think, understand it, because else you won't be able to run stuff, especially not the stuff you wrote yourself. But also it gives you more confidence on dealing with certain aspects of the command line. So I'll just bring up a Linux console. Let's see if that's visible. By the way, my camera has failed me, so the stream will be without me, but just with the slide deck, basically, which is suitable. So all right. If you run ls in the command line, you generally get a list overview of the current directory you're working in, right? Such as I've done here. So quite straightforward, no magic there. And as we know now, that any command can have potentially a large number of potential parameters. ls is a standard command, but most people generally run this not just as ls, but substitute it with the alias for ls-la, for example. Right? And what that does is it gives you a slightly different output. You don't just see the obvious files and folders in your directory listed briefly, but actually you want to see the long expression, the long listing format, more details, and A stands for all. So you can actually combine those parameters. and give you a bit more overview. So I'm running this command right now, ls-la. You see it's quite different. It's no longer just a listing of the files, but actually gives you more files. That's not necessarily helpful, but you know, but it also gives you a long listing. So this does two things to you that I want to get at here. So on the one hand, you see all the files on the right side. Notice that some files in directories, how you differentiate them, we're going to see it in a second, actually start with a full stop, with a period, right? And that's the Linux way of hiding files. So files that start with a dot or period are hidden files. In Windows, you would need to right-click, select properties, and say it's a hidden file, but that's the convention there. So if you just create a file with a dot in the beginning, you will not see it in the conventional ls, but you would see it with ls-la, right? So sometimes important if you do that you can figure out how to find all your files, right? So that's the A option for the ls command. The other one is the long format that gives you much more information compared to what we had before. And it also gives you very cryptic information. Starting on the far left with those kind of, you know, matrix-like schema that is sometimes sparse, sometimes very complete, followed to some usernames, we get to that, sizes, last modification date, and of course the name. And what we talk about now is the stuff on the left side. That's the key idea there. And that's the overview of the permissions. So what are the rights that individual users have to a given file? And that's the key idea. And the structure there is largely as follows. We have kind of, 10-bit representation there. Bring up my slide set if I may. Maybe fire. You see kind of that in kind of abbreviated form. So that's the permission system basically there. So you have a 10-character representation, and it basically boils down to the left one, the far left one, being meta information. It indicates, for example, whether a file is if it's a file, if it's the directory, if it's a link. In Windows, we have the notion of shortcuts. They're usually characterized by having the extension .lnk, link, but in Linux, there's an explicit representation for link, but there can also be something like B or C. So in B, for example, stands for block device. Okay, why device? Why do we deal with devices when we talk about files? Anyone recalls? Yeah?
Everything's a file element.
Exactly, right? Ideally, everything is kind of reduced to a file representation in Linux, so therefore it can also be devices, right? B being block device, that's something like, what is a block device?
Like, for example, contract.
Yes, right? So everything you write in blocks too, right? Or is managed in blocks. In contrast, the character device, what's that?
Your keyboard or mouse.
Exactly, right? So it's a single character that's transmitted every time. That's typically a keyboard. Cool. All right, but just, you will hardly see that. The only time you see B and C, you actually find it in a def directory. So that's where the devices usually live. In all other cases, it's usually a DL or a dash. So, and dash stands simply for file. That's a regular file. Okay, that's the standard case we're dealing with. And D is the directory. Those two cases is something you'll commonly see. Here, in this example, for example, we have a lot of files, just simple dashes, the leftmost character, or D standing for directories. Right, so the rest that gets more interesting. Now we have, 9 further bits, if you like, that we need to be dealing with. And that's the conception of the Unix permission system, because it's true, it's the same for all Linuxes. So if you learn it for Ubuntu or whatever else, you will know it for other systems as well. That makes it very consistent. And the idea is there that the permission system differentiates between 3 types of users or groups. The first one is, of course, the owner. Usually it's the single person, right? So either you individually, or root, for example, or anyone else in the system. Then the owning group. Kind of weird concept, but the idea is there. Well, if the left 3 bits are reserved for the only, how could we represent group ownership? Right, working in a group, and you want to have shared access to a given file. How would you otherwise represent it? Well, you could all log in with the same user, which is probably not a clever idea, but you can also be in the same group, right? So, and if we give the group access, then by definition, all you guys, for example, would have access, shared access to that file. Please.
Don't have the 9 type.
The what?
Of the 9.
A deny bit, no.
That's bits that won't allow to decide except for the number.
No, that's exactly. I mean, it's a bit cruder system, bit older system, so it doesn't have some certain features. It also doesn't do nested group representation. So you can't be member of a group in a group. So you can't manage, for example, an entire class consisting of groups. So those are things that need to be managed using more advanced access control lists in Linux. But you don't have an explicit deny. No, if you don't have the permission, can't access it. And then the third part, everyone else, right? So we have the individual owner, we have the group, the owning group, and everyone else, right? So very simple world, kind of works. For each of those guys, we need to differentiate between the kind of permissions, of course, and we have 3 types of permission. One is read permission, so you can see something. For example, run cat on it, look at the content of files. Then there's W, that's writing, right? So you can change and write the files. And that's the last one is an interesting one. It's the execute bit. Can you execute a file? So it's also important. That will trip us up, I think, repeatedly, the last one, because we'll forget to make files executable, right? You can write to them, you can read to them, but you can't run them. So kind of weird. So that's different, kind of a bit different there in the conception from what you would intuitively think makes sense. So UGO, user group or others, that's the convention there. Why am I using those terms? Well, we'll see later when you're specifying permissions. And then RWX, right? Read, write, and execute. Okay. Of course, it's not always easy when you specify things in Unix because the idea is to condense it. No one will ask you to specify all the 10 bits there when you do, when you change a file or modify permission sets. But in fact, there's of course a shorter version of writing things. But in order to break this down and understand it, it's important how it's represented internally. And literally those 9 bits on the right side are represented with bits, of course. If we use the binary representation and order them by their position, right, relative to the actual pairs. For example, we have the owner pair of bits, we have the group pair and the other pair. Well, we can organize them in its bit form and then calculate the decimal or determine the decimal representation of it. For example, so in the zeros position, we have the execute bit for a owning owner, right, the owning user, which would be the decimal represented as the first position 2 to the power of 0, the write bit 2 to the power of 1, and the read bit 2 to the power of 2, right? So it's quite straightforward. In decimal representation, it would of course be 1, 2, and 4. Why am I telling you all this? Well, the point is, you're actually specifying permissions in decimal representation, or as they sometimes call it, octal values. And the idea is there that we simply have 3 decimal numbers to actually represent the permission on a given file. And you do that per cluster, basically by user, group, or other participants, and basically determine the sum of the decimal representation for a given permission. For example, if you have a owner that has, which kind of is counterintuitive, only read permissions and only execute permissions, well, points out, of course, only the outmost bit, the leftmost bit would be activated and the rightmost bit would be activated, so the permission set would correspond to a 5. Right? If a owner has complete access, read, write, and execute access, it would be a 7, of course. Right? If the owning user does not have any access, what would be the decimal representation of the permission? Yeah. 0, right? 0. Okay. So, and conversely, if we have read and write but not execute access, it would be good. Well, okay. Cool. You got the gist. That's actually what it's all about. So basically, we have 3 decimal representations representing the complete permission set. So the idea is always to condense things for the sake of representation, right? So that's how it's internally represented. what people will sometimes forget is that this one here is not a 3 but a 2. People always get it wrong. Okay, why is it 421 as opposed to 431 or whatever else? It simply boils down that it's fundamentally rooted in a binary representation, right? So if you bear that in mind and see how it comes together, permissions, bit representation, binary representation, decimal representation, and then simply condense it into a single number, then it kind of makes much more sense, and you'll understand quickly how the permission systems basically work, right? So what would 0 stand for? 0 is nothing, right? So what's 1? Sorry? Something, yeah. Execute, yeah. 2. So which one is it?
Right.
Right, exactly. And write only. Nothing else, right? No execute. That's the thing. So 3? No. Write and execute. Exactly, right? So it's the 2 for the write and the x, the 1 for the x. So write and execute, we have 3. 4? Only read, exactly. 5? Read and execute, exactly. And 6 is then correct. And 7 is everything, right? So that's the idea. With those few, with this representation, you can cover all combinations, right? So that's the neat idea. That's the kind of beauty about it. So it's from 0 to 7, quite straightforward octal representation, and that for each element effectively, right? So, and we look back into our. That's correct. Hang on. Yeah, I will. I think I have a slide on that one, so that gives you an overview of all this. So, but coming back to briefly coming back to this idea here, you'll now hopefully understand what the permission sets are, right? So if you look at it again, for example, for let's take for .-rc, let's say hidden file, it will be executed upon your login. You may remember that's the file you can specify your path variable in. Path variable describes all the locations of files in your file system that are available. And you see now that we have a relatively straightforward permission set, right? So the owning user has read and write permissions, right? So the rest has read permissions, right? Anyone can read that file, weirdly enough, and the owning group can also read that file. So, but we haven't indicated yet who's actually the owner and who's the owning group, right? So we just know the leftmost 3 bits are basically representing the user, and the middle one the owning group. But we're missing the this information, and that's actually what you find here in the long representation. Well, not optimal use case here, but that's what you find in long representation. On the left side, this is the owning user, it's called user, and the owning group is also called user. Yes, so you can change those ones. Well, I'll show you how later. But if you want to change the, for example, the owning group, you can do that. The permissions stay the same, right? So the change of permission set, the bits basically, is independent from the change of the actual group, owning group or owning user. So that's the idea there. So in most cases, again, we'll see that user is the owning one. In some cases, we see things like this, where root is actually the owning, the owning user, and that's basically, well, what is root actually owning here? Yeah. Exactly. Right. In this case, the parent directory, literally. So yeah, I know what you mean. So we actually root owns dot, right? And dot relative to where we are right now is the parent directory. Recall, right? So dot was same directory. Dot means parent directory. So basically, from the local home directory, you can see that the parent directory is owned by someone else. Yeah, but just for the sake of consistency there. So let's see. Yeah, please.
The number of the
this one here. That's, if I recall correctly, is the number of blocks occupied by that file, or references by the file. I need to look it up myself. So sorry.
Number of links within the directory.
Number of links within the directory to that file, right? Then it's links. Okay, yeah. Then the blocked representation is here.
Isn't essentially subfolders?
Let's go into Mozilla. Let's see. We can just establish that quickly.
What is the number of subfolder?
So yeah.
Number of parties.
Yes. So 17 is 17 is to the upper directory. So 2 is to the same directory.
Parting to the directory.
Okay. Thanks for clearing that. Yeah. I think I have a slide that lines summarizes that somewhere. But good point. Yes. So. Looking at permissions, so check that and break, and then I'll come back to that. To disambiguate this exercise. Good. Permissions. Right. So why do we need the decimal representation of permissions, for example, and users? Well, there's two commands that are associated with changing permissions in Linux. One of them is called chown. So change owner. So that's the your opportunity to change ownership of a given file or directory. And it's used in the following way, that you say chown, followed by the user, and then followed by the file or folder name respectively. If you want to both change the user and the owning group, you need to use the colon notation. The colon notation signifies that the left-hand side is the user, the right-hand side is the owning group, right? So if you want to, for example, change from the current association to, let's say, user 2 and group 1, then it would be chown user 2 colon group 1. If you only want to change the user, you just type the user. If you only want to change the group, you only type colon group. Right, so colon group 1, for example, and then the file name of choice. If you want to change permissions on a folder name, you need to indicate using the parameter -r that it's kind of recursively applied to that folder name. So that's the slightly less exciting one. The other one that's slightly more, sorry, please. Well, for example, when you want to change the ownership, if you want to change particularly group association. So example again, you create a file or folder yourself, but want to share it with others, want to give them access on your same system, then it's sensible to invite those guys into a shared group and associate the group as ownership with the given file. That's one way. Another case I remember is that's a very not super practical one, but just imagine you need to have a hard drive and you actually need to access it with a different machine from somewhere else. And the same user doesn't exist, so you need to forcefully give yourself ownership in order to access the files, right? So that's one of the cases that I have for external hard drives sometimes, because again, users are uniquely identified by user ID, which may vary across different systems. So even though the user may be called user on both systems, actually it's a different user, because internal is represented as user ID. So those are the rare cases. But more than that, more important is simply that you know how to do it if you need to do it, right? chown. Is the command. You had some comment. Conversely, we have chmod, right? So that's the modifying the actual permissions. And you have two ways of doing this, of course, as usual in life. But fundamentally, the idea is to use the decimal representation by default. For example, so chmod and then 740, that would mean, what is 740 stand for?
Everything for the user, yeah. 3D for group and nothing for others.
Good, yeah. So the owner does everything the owning group can read at least, but nothing else, and everyone else has no rights to it, right? So that's the key idea. -R indicates that it's a folder name again that you want to modify. The alternative notation that you can use which is a bit more extensive, but also more refined, you can kind of have a relative specification of permissions, is the alpha notation. That would be, you can say chmod and then u equals, so user equals, or comma g equals, group equals, and o equals, right? So user, group, others. And you can specify their respective permission explicitly using the notation you may be more comfortable with, RWX. While this is a bit more extended, it actually in principle offers one thing that's quite nice. You can actually change the permissions without necessarily rewriting the entire permission set. For example, you can just say, well, for the owner, whatever the actual permissions are, just remove the execution bit. So just prohibit execution. I don't care whether the person could actually read it before or write it before, it doesn't matter. I only care about the fact that I don't want the person to execute stuff anymore, right? So then you can write something like chmod u minus x, right? So you just remove one permission, but leave everything else unchanged, right? If you say equals, it says rewrite the entire permission set, right, for a given user. So that's something you can do with this notation, which you can't do with the decimal notation. So that's a quite nice feat. But anyway, those are two ways of specifying it. And now you should have some understanding as to why we sometimes use those decimal representation, what they stand for, right? So if you do it, 2 or 3 times, you kind of get the gist of it.
What's the difference between G plus W and then O equals R?
Right. So in this case, yes. So to complete the example here, U minus X would mean remove the permission for execution. G plus W gives the permissions for writing, irrespective of all other permissions. So even if the person can't read, let's say, the file, it now can at least write the file. And for all others, give them read permission only. So if you say equals, it means rewrite the entire permission set. That means you can just read, but no longer write and no longer execute, right? So if you want to do those kind of modifications, this notation is easier. But other than that, the decimal notation is actually quite straightforward once you do it twice. Other questions regarding this for now? No, good. Okay. Some details on the semantics of the permissions. So RWX, we know this now. They're slightly different for files and directories. That goes in the direction of the question asked here before. An R on files just means you have the permission to read files. Writing, the obvious permission is to be able to write and modify files. Whether you actually allow to delete a file, it depends on the directory you're currently in. If you have write permission on the directory, you can delete files there. And the X, most importantly, is to actually allow the execution of files. And that's super important if you're writing bash scripts. We will not do that in this course extensively. We will definitely do it in another course. But if you come across a bash script, you sometimes need to make it executable, right? So even if you didn't write it, you need to tell the system, hey, you can execute this thing. And then you need this permission as well. Otherwise, you will have a bit of an issue. So if we, well, just let's use something. So if we, for example, write a so that would be a classical bash file. You have a signifier in the first line that just tells the system, hey, what default interpreter should you use for executing the rest here? It tells the system also, because of the this so-called shebang line of the exclamation mark, this is the executor and this is an executable file. Okay, good. So let's save this thing. And call it temp. So if we look at our newly created file, it's called temp, which is probably not the most expressive name. We don't really have execution bits. It's down there, and it's the default permission set is RW, R, and R. So it basically means the owner can read and write, everyone else can read it. So everyone can read this thing. But if you try to run it right now, and how we run a file is, well, we need to, a bash file in particular, we need to indicate the directory you want to run it in. In this case, I just say /, meaning in the current directory, run the file temp, right? So if I try that, it will tell you, well, you know, it understands it needs to execute bash in order to run the file, but it tells me also permission denied. I'm not allowed to use that thing, to use that file. But if I now then, for example, chmod, give myself full rights as a user, the group limited rights, and anyone else no rights on that file, chmod 740, for example, afterwards, it should be relatively straightforward to actually run this file. And then you see that's actually output. Echo of hello world, right? But if you see permission denied, that's just the kind of earmark. Bear that in mind. Usually it means you don't have adequate permissions. Can be two cases. Number one, you need to be super user. You need to run sudo if it's another command, or if it's a bash script, you most likely need to flick the execute thing. Yeah. Those two things, please.
You can also pass, without giving the execute right, you can also pass the file to bash.
That's correct.
So type bash and then the file.
Yeah. That's right. So in this case, you bypass the actual permission on the execution file because it's just an input argument to an executable, right? When you have the, for example, bash itself is executable, right? So in this case, you solve the problem outright. But what you do is you are constraining the system from actually interpreting the shebang line, because what happens if you run it in fish, which is in another shell environment, for example, or in the original Unix shell, SH, right? So, so you're preempting that choice there. But yes, of course, that's the easy way out. Yeah.
And also, if you just want to give quick execute rights to everyone, then you just do chmod plus X in the file. Then you give execute rights to everyone.
Right. Yeah. Okay. Thank you. So chmod plus X exactly. So don't differentiate between user, group, and owner. Right? Yeah. Cool. Okay. Just that as an. Those are more like the pointers for, you know, in case you experience issues and you don't have permissions, what are the pathways to go there, right? So, good. The last thing is, of course, complementary directories. For files, we now know, okay, read, write, execute, quite straightforward. Directory is a bit messier, if you like. So, read permissions refer to the ability to list the directory content, right? You can run ls and stuff like that. The write one is about adding, deleting, or renaming files in a directory. That's context of having write access to folder, and executing is basically the idea to be able to actually enter a directory, into a directory and access files there. Right? Listing a directory can be done from the outside. So read permissions is not the same as execute permission in this case, because you don't necessarily need to enter a directory to list its contents. But if you want to actually enter the directory using a cd command, you need to have execute permission on directories. So it's slightly counterintuitive. So just bear that in mind. If you deal with directories, the semantics are slightly different. Okay, so I think I'll give you a break until, what is it, 9:20?